This multiple choice question is about organic chemistry, in particular oxidation reactions of alcohols, but also of aldehydes. So the first thing I would do to think about this question is I would draw out the structure of my 4-hydroxy-butanal. So but means I have 4 carbons. Butanal means we have an aldehyde. Now, when we name aldehydes, we assume that the carbon that the aldehyde group on is carbon number 1. So for hydroxy, I need to go all the way to the other end of the chain to stick in my OH group. And the reason it's hydroxy and not ol for alcohol is because the aldehyde takes priority in the name. Okay, so what's going to happen when I reflux that with acidified potassium dichromate excess? So all the groups that can react are going to react as much as possible. It's under reflux as well. So obviously my carbons are all going to stay where they are because oxidation doesn't change the number of carbons. My aldehyde is going to change to a carboxylic acid. And then that OH group on the other end is a primary alcohol. It's at the end of the chain. So that also is going to end up as a carboxylic acid. So this will be my molecule that's butane dioic acid, or butane 1,4-dioic acid if you like, but we don't really need the numbers. So now let's group together all the atoms. So there are 4 carbons, there are 6 hydrogens, and there are 4 oxygens. Now that's the molecular formula, but it's not the simplest whole number ratio, which is my empirical formula. That would be C2H3O2, which is why we get the answer D.